This video will start with the pictures I took while doing the modification and end with a video demonstration. This modification was so I could use other power sources besides a 9-volt battery in my Ced Chronograph. I got tired of getting to the range with the intention of performing one thing or another with the chronograph, and when I got there, the battery is almost dead. And if the chronograph will work, it just gives funny readings. That often meant my trip to the range was wasted for my purpose for the day. I got tired of buying 9-volt batteries and having to always keep spares. This is the only device I have that uses 9-volt batteries. But I always have power tool batteries around, and I'm pretty handy with a soldering iron, and I can usually fix what I screw up. You're going to need a few things to do this modification. And if you do this modification, I'm sure your warranty is void. First thing you need is a mini 360 buck converter. It's very small, as you can see in the picture. A buck converter is something that steps DC electricity down to a lower voltage, and there is a voltage range for input and output for these modules. We need it to output 9 volts. Whatever battery or DC power source you use needs to be more than 9 volts but less than 23 volts as per the specs of the module. The output voltage is adjusted with that tiny screw on the board. So you're going to need a set of mini screwdrivers for that, and a digital voltmeter so you can set the output voltage to 9 volts. We're going to need a couple of other things. Some sort of connector to get the power into the unit. I chose a standard barrel jack connector at the unit. They are a proven system and would be easy to install in the space I had to work with. Then I made an adapter to go from XT60 to a barrel plug that matches the jack I chose. You will also have to solder the input and output wires onto the circuit board. The back of the board is clearly labeled which side is input and output. Leave them a little long, and they're going to need to be very thin. I think I used 20 or 22 gauge silicone wire, but anything will do as long as the case isn't pinching it when you close it. You're going to want something stranded that's flexible. The empty space inside the unit where the converter will be placed is at the opposite end from where the wire connectors have to be made. So I anchored all the wires to come off of one end of the board with hot glue. Then for a little extra security, I put it inside of some heat shrink tubing I had for 18650 batteries. It was a perfect fit for this project, so that's what I used. I took the screws out of the bottom of the case and gently opened up the case of the chronograph. The bottom of the case with the battery holder in it comes loose and folds away, but take care. The battery holder is in the bottom, and there are 2 sets of wires still connecting the 2 halves. One set is for the battery, and it was so long ago that I did this, I forget what the other wires go to. I laid out what I had and figured out where everything had to be. I had a big open space on the side opposite the battery compartment for the converter. I decided to put the power connector on in front of the battery compartment. Where I put it is best seen in the video portion at the end. I laid out where everything had to be so I could figure my wires out. The output wires will be connected onto where the factory battery wires connect to the chronograph board. The input wires will be connected to the barrel jack. I want to still have the option to use 9-volt batteries if I want, but do not, and I repeat, do not in capital letters have a 9-volt battery in there and then use the external power source at the same time. Here's a close-up of where they are so you can see the yellow and white output wires connected to the same place the battery is connected. For God's sake, keep the positive with the positive and the negative with the negative. Here you can see where I drilled a hole for the power jack to go through the case. I had to remove some of the material behind the hole. You will see it better in another picture. Here's a top view where you can see I had to remove a little bit of structural material behind the hole. You can refer back to other pictures to see what it looked like before I drilled the hole. And here's a little section I had to remove from the bottom of the case to get it to close properly. Here is a close-up of the wire connections to the chronograph board. The output wires of the converter connect to the same place where the battery connects to. Just be sure to connect the positive output of the converter to the positive battery connection on the board, and the same for the negatives. If you need to refer back to any image for a greater length of time, you can just pause the video. Okay, here's the modified CED M2. On the left side is where I put the jack for the input. It's right below the battery compartment, and there's no battery in it. Here's the adapter I made to go from this jack to the batteries that I use. I'm heavily invested in the XT60 connector line. And I'm going to plug this meter in so you can see the voltage coming in from the batteries. Alright, here's a 3S lithium battery I put together. And that battery is reading 12.29 volts. And it works beautifully. Alright. Now I'm going to plug in a Milwaukee battery just on one of those power output pucks. Sometimes they come with nothing, with just wires. Sometimes they have a USB output, or in the case of some of my other ones, they also have a USB output and a 12-volt port that you can pull just 12 volts out of this 20-volt battery. But plug it in. .20.5 volts. And there it goes. Now the maximum input voltage, it's listed in the specs for that little buck converter, is only 23 volts. So I wouldn't use anything with any bigger voltage than the drill battery. But for me, the 9-volt batteries, they would last a day. And after that, they would go wonky on you. And I got tired of buying those things. I didn't need them for anything else. I didn't keep them around. And I had the means to do this, so I fixed it up to use the batteries that I have and I use all the time. And it made this thing more usable for me. Thanks for watching.